Hey, we got another bit of equipment here on the bench. I just got this one the other day. It came with a the mainframe that this thing goes in, and that's what I was really after. But this was in there, and it's a nice little bit of a test gear, so I thought we'll have a look at this and see what we can do with it. So it's a Tektronix piece of gear, of course, because this channel seems to do a lot with Tektronix gear. I keep picking the stuff up for good prices, so that's just what we got. This is a AFG5101 programmable arbitrary function generator. Good for 12 megahertz. It has the usual sine wave, square wave, and triangle wave there, but also you can give it arbitrary waveforms, and it will kick it out on the output there. I believe, I haven't looked deeply into it, but I believe the arbitrary waveforms, you can load them in via GPIB. There's no other communications on this thing, it's only GPIB, so I think I'm going to have to figure that out. Hopefully Tektronix have, or had, or somewhere is available some software that I can run on my PC to make waveforms and send it through, but if not, not sure. I'll have to research that and see what the go is. But anyway, we can get it running with the normal just function generator outputs. That's not a problem at all. So yeah, this it's a 3-bay TM5000 series. I've done a few videos on some TM500 series, which is like kind of the older revision. Generally didn't have GPIB, and a few slight differences here and there. This is the 5000 series, which mostly cross-compatible. So TM500 modules, mostly, not all of them, but most of them can go into a TM5000 mainframe. But the TM5000, I don't believe, can go back to the TM500. You'll see mainly because of these little black pips. That stops you from actually sliding this into a TM500 module, this TM5000 module into a TM500 mainframe. Whereas the TM500 modules don't have that, so they will go forward to the TM5000. Not all are cross-compatible, but yeah. Anyway, let's get on to looking at this thing. So there's a bit of a scratch on the front, but I might be able to just smooth that off a bit. That's not a big deal. I'll give it a bit of a polish on those BNCs, but let's have a look inside and see what we got. So it looks like we can take the back panel off pretty easily, and it looks like we've got cards on a back plane connector. Well, it's probably a front plane connector because it's at the front here and they slide in from the back. So let's get this thing open and see what's inside. So there we go. We've got a few cards, one empty slot. That's for option 2, which is not phase locked. It's like a frequency locked oscillator board thing for better accuracy. I have to check those plugs. That's an Amphenol plug down there. A little bit hard to come by. I think they're actually obsolete. I had a bit of a sneaky peek on eBay and whatnot, and there's a big one here, and I can get those for not too bad a price. But the smaller ones, like on this side, I've got to find a source for them. To calibrate this thing, I'm going to need to make an adapter cable so I can take the card out and I can access the board underneath, because there's adjustments on both boards. I need that for both sides, so I need to make a small kind of like adapter cable and a large adapter cable so I can fully adjust this thing. But we'll come to that later. Let's see what's inside. So we've got the CPU board here. We've got our firmware here. This is just a standard EEPROM. What's that? Yeah, 27256. Yeah, standard EEPROM chip there, UV erasable. That's version 1.2. Now, I had a bit of a poke around online. I found version 1.3, and a nice member on the TechScopes groups.io page has sent me version 1.4, so we will upgrade that to version 1.4. I'm not sure what the changelog is, what's the difference, but it will. It's definitely not going to hurt to upgrade that. I've got the gear to do that, so we'll run through how to do that. Looks like we got a what's this? Oh yeah, that's a RAM chip socketed. They probably expected that might need to be changed every now and again, but we've got the RAM chip there, and we got another RAM chip here. I think this is the what they call the scratch RAM. So I believe the way this basically works is, back when this was built, RAM was expensive, so they've got the bulk RAM here for all the general, like just using the unit. But when you're running the arbitrary function generator function, the arbitrary function generator is running away, and you want to load that, whatever your waveform is, really, really quick. So this is faster RAM This is dash 12, this is dash 10. So this is a small amount of RAM, but faster RAM. So rather than putting like a large amount of fast RAM, which is much more expensive and blowing out their design budget, it looks like they went for some slower RAM, a big lot of it, and then they went for a small amount of fast RAM just for that arbitrary function generator function. So yeah, that's I believe that's what they've done there. 8085, that's probably the CPU, or this one here. No, that might be a peripheral controller. I'm just guessing here. We've got the GPIB gear over here, and we've got a battery that hasn't leaked. It looks like it's fully sealed, probably potted. Renata 125-1. That's going to have a potted little cell in there. And when I was looking at the schematics for this, there are some diodes in there too. It's got like a bias diode so that that doesn't discharge and whatever in the wrong way, or when you apply power, it doesn't try and charge that non-chargeable cell. So I will be replacing that because that is a known thing where that will run out. So you can't get those anymore, but we can make one because it's just 2 diodes and a coin cell. So I'll probably have that not potted anymore with my little piggyback board, my little adapter board, and it'll be like a replaceable coin cell, like in the BIOS backup battery in your PC. Just flick it out and put a new one in. So that will be fine. So let's pull this board out. These should just slide out. There we go. Bit more logic and whatnot under there. We've got the connectors coming out here. So that's probably doing some sort of signal generator sort of stuff. I'm not sure what this board actually does. I'll probably just put it on the screen somewhere here. And yeah, we've got like 1 electrolytic there, a few tantalums, but we'll test all those tantalums. Unless they're actually causing a problem, we won't need to replace them, and they don't look like they've overheated. They tend to go short when they get old. It's a known thing with older Tektronix equipment, especially like much older stuff than this, talking 70s, maybe even 80s. You got to watch out. I've had a few of them go short. I've actually had some that I had something working. I did some unrelated repairs, like clean the BNCs and all that sort of gear. Then I turned it back on and wouldn't work, and it turned out in that time one of the tanks went bad, so I just replaced that and it was good. So yeah, we'll be able to easily check that out. You can check them with your multimeter. Make sure you get the polarity correct, because tanks don't like being reverse biased. But yeah, they're marked with a positive lead, and you test that, and as long as they don't have a resistance down in the single digit ohms, or even like low double digits, they're probably okay. There's a the electric there, and there's electrolytic here. What's that? What brand is that? Towa brand, Towa. Never heard of them. Towa brand. 105. No, that's 85 degrees rated. So maybe I'll pull 1 or 2 and just check it, because I don't want to just go and shotgun all the caps, and if I don't need to. But they're pretty cheap anyway, so maybe not. Other side. Oh yes, we have got some interesting capacitors here. These ones, they're Philips. We will definitely be testing some of them. The Philips ones like these, they are known for going bad in a lot of equipment of this vintage. Tektronix multimeters, benchtop multimeters, yeah, they're a known thing in there. Like there's a lot of equipment where you see these and it's replaced on site. Yeah, these are Philips as well. There's a similar ones. Vishay, I believe, have a similar looking capacitor that's wrapped in like blue plastic, but these are definitely, they say Philips on them, and yeah. So I'll be definitely testing those to make sure they're up to snuff, because this is all the power supply section here. So we want to make sure our power supply is nice and clean, so we get an output that's nice and clean. If we pull this out, another board there that does something. I'll put it down here. Looks like we've got a few hybrids and a hybrid up here. They look like they would be able to be replicated if they went bad, but these are looking pretty good. There's nothing burnt there. So yeah, you can see it's all these adjustments everywhere. So if that's plugged in, that's a power supply, that's got to be plugged in, but you can't adjust it. That's why I need to make the adapter cable, so I can take that out and still use the extension cable to then get in there and tweak things with my tongue in the right position. And I just noticed something. We got a bodge. We got a genuine dyed-in-the-wall bodge. Look at that. I wonder if that's a... oh, there's no burnt traces, so it's not a repair. Yeah, That's probably a tech thing. What's the it's 10159, IL 10159. So it doesn't seem like a super early serial number, but yeah, there we go. Got to have a bodge. Ain't complete if it's not got the bodge. So far, we've got to put a new battery in. So let's plug this back together, turn it on, and see what happens. Alright, ready to go. Sorry about the wobble. I'm hand holding on my phone at the moment because my camera is up there. So that's kind of a bit difficult to take off. So let's turn it on anyway and see what we get. V81.1 version 1.2, save RAM failure, error 340. Okay, now have to look at that. That may be the battery, if the maybe the RAM's just getting cleared because there's no battery backup, so we'll have to figure that out. But it is showing a screen. I don't know if you can see that. That is really, really bad. That's so faded. Let's see if we can turn the backlight on. Special, what was it, 220, enter. Backlight off. If you enter, wow, I can't even see it. Barely see it. Let's get that close. Can you see that? How about we turn the intensity up? So I'm pressing the up button here. We'll take that right up to the maximum. 99. Okay, let's turn that on. Ugh. I turn the lights off. Let's see what that says. Yeah, you get really, really dim. And actually, I can hear a really faint whine. I bet you any amount of money that's a electroluminescent panel. Because back when this was made, blue LEDs probably didn't even exist. So that is just faded with age. That's just an old faded electroluminescent panel in there. So we have to fix that. And that RAM problem. But that may be the battery. So that might be two birds with one stone with any luck. But yeah. So it seems to turn on anyway. So let's get rid of that. And I'll plug it into the scope, or here, from here to the scope, and see if we get an output. Alright, so we've got a sine wave. We've got it hooked up to the scope with a 50 ohm terminator there. The scope's going ready to tell us what's happening. And we got 1000 hertz at 5 volts. So let's turn that on. And look at that. 5.24 volts. 1000 hertz, 1 kilohertz. Looking good, sine wave. Now let's flick that over to triangle. That's the same. And square. Nice. Now, I want to try that at, what do we got? Sine wave, let's say 12 megahertz. Enter. The scope's freaking out, so let's just change the time base. There we go. What's that saying? 12 megahertz, 4.44 volts. There's a little bit of loss in the RG56 cable at the higher frequency, so that's not a problem. So that is looking good. Now what about our triangle? A little bit rounded off there, but that's kind of to be expected at these frequencies. See, that's rounded, that's a sine. There's our triangle. What about square wave? Yeah, square wave is rounded off too, but that's fine. I mean, it's not exactly a huge powerhouse, but it's working fine. That's great. I'm happy. So it does actually functionally work. Alright, so on the subject of these capacitors, these Philips ones, I think I might have spoken too soon because I pulled them all out, as you can see here. They're all taken out of the circuit board. And I gave them a test, and they test fine. They're like better, equal to or better than the datasheet specs. They're a Philips ASM021, and I did find the Philips datasheet for them. Philips components, ASM021. And they got here on the side, it says 021. So that's what they are. And it turns out that Vishay have an ASM021, so I would not be surprised if they're exactly the same. Vishay probably bought the rights or the technology or the plans or the blueprints or whatever from Philips when Philips decided they didn't want to make capacitors anymore. But anyway, I've got the Philips data sheet and it has all the information. It's fantastic. It's got, you know, rated capacitance, rated RMS ripple current, leakage currents, dissipation factors, ESR, impedance, even equivalent series inductance. It's a really good data sheet. A lot of capacitors data sheets, they don't have all this information for modern capacitors unless they're a special capacitor. But anyway, this has got all the data. So basically what I've done is I've put them on my my LCZ meter, my HP4276A, and then I test them on there. It's all at 100 hertz, so I did that at 100 hertz, and then I put them on the power supply to run them up to their full rated voltage, and through the Keysight benchtop multimeter on the current mode, and to measure the leakage current. So basically the big ones, they're a 470 microfarad at 40 volts. And when I tested these on the LCZ meter, I set the DC bias up to 40 volts. So they were tested at their working voltage. So we've got the four of them here. The ESR needs to be below 0.404 ohms. So below 0.4 ohms. And they are. They're at 0.29, 0.35, and 0.33 and 0.33. So they're below the rated specs for the ESR. Fantastic. The actual capacitance, they're meant to be 470, and I measured them at 470, 465, 467, and 485. Now they're plus minus 20%. That means they've got to be within 376 up to 564. They're bang on. Fantastic. Not a problem. Now the leakage current. You can have a capacitor that measures okay, has all right ESR, but they leak. And really old tube gear has that problem a lot. And often with a leakage, it means that the way that the meter measures it, it charges up and then discharges and times it. Because of the leakage, it takes longer to charge up, and then it thinks it's got a high capacitance. But this wants, after 5 minutes at rated voltage, 42 microamps. 42 microamps, right? 2.2, 1.6, 1.5, 1.8 microamps. There's no leakage at all. They're fantastic. They're perfect. And it's the same story with the 25 volt ones. The 25 volt ones, they're a little bit closer to their rated specs. So the ESR is at 0.48 ohms, and we got 0.48 and 0.46. And the leakage, 28 microamps, and we're at 4.8 and 6.4. And the capacitance is 402 and 405. So that's well within tolerance as well. So these capacitors are perfect, ready to go in the circuit board and keep living and doing their job. I'm not going to replace them. Alright, now as for this module, I've removed the battery already. The battery pack. It says it's 3 volts. I'm pretty sure it's not going to be anywhere near that. From the data sheet, I found the schematic. It's got two 1N4148 diodes, as I mentioned before, and the battery in there with 4 pins. So to measure the battery, we want to go between pin 1 and pin 2, which are at the top. So let's get the multimeter out and see what it says. So pin 1 is ground, 2 is positive. Yeah, you can see that there. Let's see what we get. Huh. Absolutely nothing. Yeah, nothing. 42 millivolts. Not much more than just the floating voltage when I'm waving these things around. So that is as dead gets. So that will need to be replaced. And it looks like we've got a larger footprint area. I think it goes that way. So we've got the larger footprint area there, which is nice. So I've got a bit of wiggle room to play with. So we'll make a new one of those, and that will go in there. Now, as for this other stuff, the RAM error, that could be because of that. It probably is because of that, but one of the RAM chips here is socketed. So, why not give it a test? I've got my retro chip tester here, which is fantastic. I use it all the time for testing 7400 series chips. Chip Tester Pro. from the 8-bit museum. Fantastic stuff. So we want to go to, yes, SRAMs. Oh, hopefully you can see the screen. Might be a little bit hard to read, but this is a XX256, right? XX256, 32K by 8. That's what this chip is, a 32K by 8. So I'm going to pull that out and then stick it in there. This might take a little bit of time, so we'll see how we go. Well, that's testing now. So once it's passed or failed, we'll be back. And a few minutes later, test passed. Fantastic. That chip is good. So let's put that one back in. Now the other RAM chip, that scratch RAM or whatever it's called, that is soldered into the board. So I'll desolder it. Maybe I'll socket that, just because. So let's get this out the way. I'll fire up the soldering iron, and I'll get this thing out, and then we'll give that a test and see if that's good. Alright, so now I've got that pulled out. That's a 6264. So let's find that. 256, 64, there we go. 8K by 8. And let's see what happens. And we get a test passed. So both RAM chips are okay. So that RAM issue when we boot up must have been from the dead battery. But that's fine. We know that for sure that the RAM is good. So even that we didn't find the problem, we still have narrowed it down away from the RAM chips. So I've got to get a socket. I'll get one of those in a bit. But next is to deal with the firmware upgrade. So if you pull that one out, that's a version 1.2. So I've got to erase that and then we'll reprogram it. I've got one of those TL866 universal programmers, the Chinese one. They're actually pretty good. So we'll program it with that, but first I've got to erase it. So I have a Leap Electronics EEPROM eraser. Model LER-121A. So I'll just get it all out here. Now this has got a ultraviolet, I don't know if you can see in there, there's an ultraviolet fluorescent tube inside. Maybe I did a video on this ages ago, I can't remember. Maybe, maybe not, I don't know. Anyway, this is going to erase our EEPROM. So we'll plug the power in. And then I've got to take off the label. So carefully, just carefully try and cut myself. There we go. I'll give that a bit of I'll give it a bit of clean up later. That can sit in there on the drawer. Now I've got to figure out how long, because if you do it too long you can damage the chip. I'll give it 20 minutes and then I'll test it, because I can put it in the programmer and then check to make sure it's blank. So I'll do that and I'll just incrementally give it more time until it is blank. So yeah, I'll be back in a bit. And there's our chip all done. I just programmed it with that TL866 programmer like I mentioned before. I won't bother showing how to do it. If you need to know how to use that programmer, or if you've got your own, you probably know how to use it. Yeah, check out the videos, other videos online. I put a silver sticker on there from the label maker, just with the part number 050-1201, the year and week 2236 and version 1.4 rather than version 1.2 on the Tektronix sticker. So yeah, all the information's there. Silver to try and reflect away the light, and we can stick that in to there. Done. We have upgraded the firmware. Now, as for erasing it, I had a look at the data sheet, and it actually does have the erasure exposure, UV exposure information. So it says we need an eraser that kicks out what was it? 2,537 angstroms, which is exactly what this does, surprisingly, because that's what it's designed for. And it says that to erase that chip, you need to expose it for 15 to 20 minutes with a light intensity of 12,000 microwatts per square centimeter. Now, this one produces 5,000 microwatts per square centimeter. So give or take about 2.5 times less than what the datasheet says. So that means we've got to expose it for 2.5 times longer. I gave it 45 minutes because that felt like, yeah, it's all right. It's not too long, not too short. Then once it was done, I put it into the programmer, and I can actually test. A lot of these programs you can test to see if it's a blank chip, and it came up blank. So I programmed it, and it was fine. So we're done. So before you take the front panel off, you're going to have to pull the 2 pull tabs out, 1 and 2. They're not too difficult. This one is a little bit of a fiddle because you've got to reach in a little bit further. But I'll show you how to do it with this one here. So basically you can see when I pull it, it pulls this part here, and then this little bit here pops up. And that's what unlocks it underneath. You can see there as I pull it. So what we need to do is we need to release this part here from the inner section there. So if you pull it forward, hold it there with your finger, and you push it back in, you can hopefully you can see there it's kind of popped up a little bit. Get some tweezers and get underneath there, and if you lift it up carefully, it'll come straight out. Don't bend it too much. You don't want to break it, but just a little bit of a flex and it'll come out. And then to put it back in, put it back in the hole and push it forward, and it'll sit back straight in there like that. Easy peasy. So we'll get these out. The screws on the top and the bottom are actually different lengths. So be aware of that when you're putting it back together. There's 6 on the top and 6 along the bottom. And the short screws go on the bottom. The long screws go in the top. And we're in. So that was pretty easy. There's just 6 screws on the top and then 6 corresponding screws on the bottom, and then this will come out. There's 2 connectors to undo, and then this whole thing folds down. These are all soldered connections. It would be nice if these were like the Peltola, I think they're called Petola connectors. Those little coax things that Tektronix seems to love, but obviously cost versus benefit wasn't there. But that would make that easy to disconnect. But you don't really need to get into this part of the circuit really at all. No, not for any calibration or anything. Only for what we're doing now, which, you know, under normal operation it wouldn't be necessary. So that's fine. There's enough slack there to open this up. Then there's a bunch of screws on the back, and we can take the board out. Pretty easy. And that is cast aluminium. None of this plastic rubbish like on all the other TM500 modules. That is nice. Yeah. So let's get that out of the way. And here is our front panel with our LCD, and there's the inverter for the backlight, the electroluminescent strip for the backlight. So apparently we can replace this with a standard module. That's kind of a standard sort of size there. So I'll measure that up and make sure it's going to fit something I can get off the shelf, and we can put something else in there. Now, these days we don't use electroluminescent anymore. We use LED, so I'm going to have to figure that out. It might be just a case of removing this and then connecting the LED to whatever's supplying this. It looks like we've got yeah, two connections in and two connections out. So it'll be positive, negative in, and there'll be the positive, negative, or not positive, negative. It'll be AC, wouldn't it, for electroluminescence? So it'll be the AC output to the strip there. And actually, here I have a spare one. This is from Geiger counter, which I built years and years and years ago, and not featured on these channels before I had the YouTube channel. But this looks like it will fit exactly. So that does lend credence to the idea of just replacing it. The screw holes, I've had to chop off the top corners, but that's no big deal. This is the wrong colour. This is a green one. I don't want the green. I want the white backlight. But they line up, and instead of having the backlight coming off the side there on this one, it's the last two connections on the left. So I'll just put some little jumper wires, just like what they've done, except just from the opposite side, or the other side there. So it looks like standard modules do fit. Fantastic. So that's a bit of a sanity check that's just passed. Awesome. And after a small wait on the postman, I've got a new screen. I went for a white backlight with black text, just so it looks a bit more nicer than the blue or the inverted colours. Just from eBay, so not too expensive, because these things are pretty cheap these days. Okay, so lift that out, and hopefully this one just drops straight in. So I've got the I put the screws back in just to keep them safe. Let's see if they fit through the holes. Oh yes, they do. Fantastic. Don't have to drill anything out. That is great. Should just, yeah, it all lines up perfectly. You can see here, you got all the pins coming through, but there's two there that aren't being used. That's for the backlight, and that's going to be connected to the two pads just there. That's where the old inverter used to be. So we'll have to wire from those two pads on the right hand side. Just loop them around and into there. Little short wires, that'll be easy. And then we can get this thing working. So there's a screen all installed, looking really, really good. I did find there's a few modifications I have to do, nothing too major, but the first one is that the new screen is actually 2mm thicker than the old screen. So the old standoffs, the brass standoffs, they're 8mm tall. I had to replace those with 6mm ones. I just used nylon standoffs there. Straight in, I used threaded ones. I just drilled them out to, like, you know, 3.5mm or so. But yeah, any sort of standoff that's 6mm tall, 4 of those, and that will bring that screen down so it's at the original height. Also, the light seems to leak a little bit out of the end of the backlight there, and it shines onto the LEDs, and when the front panel's on, it makes those LEDs kind of look like they're turned on because the light's coming through the LED. So I put some heat shrink there. It's like 5 or 6, maybe 6mm heat shrink, something like that. Something will slip over there, and it's about 14mm long. So when that comes up to the front panel, the heat shrink is acting as a light barrier, so that you don't get light leakage coming through. And then the last one is to do with the contrast. So it seems the contrast is a lot different on this. I found that when I put this in, it was really dark. It was all just black, and I had to change the settings all the way down to the lightest setting to see anything on the screen. So what I've done is pin 3 from the left is actually the contrast pin. So what I've done is I've pulled the pin out of the header there. I just desoldered both sides and used my needle nose pliers to pull the pin out. And I've put a resistor there, 3.6K resistor. Just loop it from one side around the outside and back in again. And that sits there nice and flat. And it brings that contrast setting to your dead center. So at 50, like from 0 to 100, 50%, this is perfectly in the center of the its contrast range. You might have to change that a little bit depending on your screen, but 3.6K should be a good starting point. I'm also on the housing where this goes in. I'm going to put a little bit of Kapton tape, just because that's an aluminium piece that goes over the top, and it is pretty close. So I'll put a bit of Kapton tape inside there so that resistor doesn't rub. If you've got an 1/8 watt resistor, this is a 1/4 watt. If you've got an 1/8 watt resistor, it'll be a bit smaller, so it might fit in there nicely, but the 1/4 watt is fine. So that is ready to go back in. All right, time to deal with this dead battery. So I've got a new CR2032 battery holder, a nice one with shiny gold plated contacts, and some diodes. These are 1N4148Ws, which are the surface mount version of what's inside there. We'll come to that in a sec, because there is one other thing I'm doing, and that is dealing with all this stuff. So I got some connectors. I was looking at the connectors on these, and they're like an Amphenol C133 714A 96P part number, completely obsolete. And I'm scratching my head trying to figure out what sort of connector they are, and it turns out they're really common. They're known as Eurocard, or DIN 41612, DIN 41612 or Eurocard connectors. They're cheap as chips on DigiKey and Mouser and whatnot, and so I bought a bunch of them because I'm going to make extender cables. To calibrate this thing, we need to make extender cables because the cards kind of slide in and you can't get into the inner card because the outer card's in the way on both sides. So you need two extender cables, one for the big connector, that big one there, and one for this card, which is a small connector. Or this card, one of the two cards. I've got to double check because I might need to make extensions for the these coax cables. They're just an SMB connector, nothing too fancy there. I'll just get some off eBay for a couple of bucks shipped from China. That's not a worry. I'll see if I need that. I'm not sure yet. Anyway, yeah, so I want to make the extension cables. So I've got a bunch of connectors to do that. So what I'm going to do is I've got my backplane connectors. I've got a 90-degree one there. That's actually for an option card. I want to make that, so I bought the connector for it. So what I've got to do is I've got like a big chunky connector. That one's going to go inside. Then I'm going to have an adapter PCB, just a little strip PCB with the contacts coming across, kind of like on both sides. I'm going to put the PCB not like that, but like that. Then to connect to my ribbon cable, which I've got some big chunky 64-way ribbon cable for this one. I've got your standard kind of connector, like I'm not sure what these are called, just a standard kind of ribbon cable connector, and then that one there is an IDC style insulation displacement connector, and we're going to crimp that on the ribbon cable, one of those on the ribbon cable there, and one on the other end. There's a little trick I'll come to in a sec, and that'll be on both ends. So then that will then plug into there, which will have an adapter PCB onto there like that, and that will let us plug it inside, and then we'll have the other end which will then let us plug it onto there, and that way we can break out the PCB, get it out the way, eviscerate the unit, and get its guts all over the table, so we can then get in there and tweak what we need to tweak with our tongue in the right position. So I've got one made here already because I was figuring out how I was going to do it. This is for the smaller connector, and there is a little trick because it needs to be a straight through. So if I bring those two connectors together, we need the top, like the top pin towards me, and on both sides, the top pin towards me to be like a straight through connection. Now if I make this, just crimp the cables on, the connectors onto the cable just as normal, well, it's not going to be like that. It's going to be like, if you imagine here, the top left and top left will be the same, right? But if I bring them together like that, well, now they're on opposite sides, and that's no good. One's going to be on this side, and one's going to be on that side, right? But that's all right if you're going to plug it into a PCB, because you want pin 1 and pin 1 to be the same, but we don't. We want the pins to be reversed, so pin 1 becomes to pin 2, and pin 2 becomes to pin 1, and then the same, pin 3 to pin 4, and then pin 4 to pin 3. So what I've had to do is flip each pair. So I've split the cable, and then each pair gets rotated and then rotated and rotated. It's a little bit tedious, but that's what I've had to do, and that makes it straight through like that, and that will work perfectly. So it's actually a cool thing about the ribbon cable I've got here is that it's, if I get the light right, you can kind of see there's sections to it. There you go, you can see the sections. So just here, it's it's kind of, they're all joined together, but in this section here, they're not. Look. So what I can do is I can actually get to the end, and then I can just split a little bit at the very end, and they hold together in their pairs, and I can, because it's open there, I can easily just twist them. Put some tape down on the table, and then stick it down on the table, and then just go twist, stick it down, twist, stick it down, and that can hold into position. Put another piece of tape on top, and I can hold it in its twisted orientation. And I've got one of these suckers, and this is a you get these cheap if you do these relatively regularly, or like with any sort of frequency. These are magic. You put that in there, and you can crimp it all down in one go. You can use your pliers, but you risk kind of like twisting stuff and damaging the edges and crunching stuff unevenly. Or the other option is to put into a vise and then tighten the vise up, and that'll push it all evenly nicely too. So I'll show you how that works when we come to that. But first of all, let's get our PCBs, because my good friends at PCBWay have given me a box of stuff. Got some PCBs made. So check out PCBWay. They do have promotions on all the time. At the moment they have a promotion. So check out their website. I'll have a link down below and whatnot. They've got a bunch of services as well, like you can get flex PCBs, aluminium PCBs, flex rigid, where it's a combination of the normal solid FR4 PCB and then flex sections. They got CNC machining, 3D printing, injection molding, all sorts of stuff. It's really, really cool. They can even populate your PCBs and make stuff. Oh, I've got some extra things here. They can like build your PCBs for you and send you a completed PCB, fully populated. So yeah, check them out. They are very good, and they always make good quality stuff. Of course, I'm going to say nice things, but because they're sponsoring the channel, full disclosure. But I keep using them because they keep being high quality, and I've never had a problem with them whatsoever. So looks like I've got a nice PCB ruler there, purple one, nice. Oh, what's this one? A little gift. My contact at PCBWay, she said that she sent me a few extra little gifts. Oh, cool! It's like a little book of sticky notes. Awesome. I go through these like candy, sticking all over my stuff, all my notes, because I forget everything all the time. Oh, nice, a pen. Sweet. I always lose my pens, and these ones are actually not too bad. Like, they're the gel pens. I like the gel pens. So that will stay over there. And oh, a blue one. Blue and purple. The colours of dubstep. Yeah, nice. Okay, so let's get those out the way. 1, 2, 3. Oh, wait. Oh, what's this? Ha ha ha. Oh. Oh wow, that's nice quality. For real, that's a 3D printed PCBWay logo. If that's a example of their 3D printing, that's really, really smooth. It must be, is that resin? It must be resin. Because the layers are so fine. That's really impressive, actually. I'm used to like the old like Prusa printers, you know, like the FDM, where it's squirting out like toothpaste. That's really nice. That's going to go on my desk. PCBWay, thank you very much. So anyway, let's get back to it. We have got, what have we got? Aha, this one here is the PCB for our battery. So these are a little bit bigger because this is the 125-1. Right, 125-1, and this one is actually a 1000-1 replacement. It's just a bigger one because it fits the CR2032 holder. But you see there's a dual footprint, right? Look at this. Bonk, right on top. Perfect. See that? Awesome. Thank you, Tektronix engineers, who decided to put the dual footprint. Really helped me out there. So let's open these up first, and then we'll get to making one of these. because these are our adapters. These are basic PCBs, like the most basic you can get. They're just like straight through. So the idea is I'll bend these pins kind of inwards like that, and that will sit in between and solder them down. And then on the other side I'll get that one and do the same. They're much closer, so I'll bend those just a little bit. Funny thing, this is 32 pin and these come in 34, so there's going to be 2 pins not used. Not a problem at all, they'll just be unused, that's all. But we'll end up with an adapter looking like that. Nice. To plug into the unit or into the card, whichever side it ends up being. And then this is the big ones. And I counted correctly. Yay! I got them right. Nice. Not much to show on the PCB, but they are very high quality, as I always say, because it is the truth. Got a bunch of these ones. Sometimes for small PCBs, they'll just fill up leftover bits in the panel. So rather than just getting the normal 5, you might get extra. I got 6, 7, 8, 9, 10, 11 of them. Nice. And these I got 1, 2, 3, 4, 5, 7 of these ones. So sometimes you get lucky. I know I got 8 because of that one over there. So I got 8 of them and 11 of them. Sweet. Sometimes you get a win. So now this one. We need 1 of them and 2 of them. I managed to get all these parts from Akihabara, which is fantastic. Let's zoom in a bit. Okay, I'm going to tape that down. Otherwise I'm going to be chasing it all over the table. Oh, my footprint fits. Sweet. I had to cheat on the width of the footprint just to get it so I wasn't going to get too close to the pins here. It's also why it's sideways or 45-degree angle, because otherwise it's too big. But that is pretty good. With that, we got it. Focus. Nice. Okay, I guess all I need to do now is find a battery. Da-da-da! That goes in there. Done. Job done. That is ready to give it a test. So I'll put this back together. We'll stick it in the mainframe again, and we'll see if it works. That looks really good. Yeah, I'm happy with that. Alright, back on the handheld phone again. So let's turn it on and see what happens. I expect there might still be a error. RAM failure. Okay, that's because there's nothing in the RAM. Because we just put the battery in. So, what's the code? Special 220, enter. Intensity is 50. We want to turn the backlight on. Alright. So then we can just go frequency. Okay, back to the home menu. Now if I turn that off, all going well. Yes, yes, it's fixed. It's done. Fantastic. That is working perfectly. Awesome. Nice. I'm happy with that, thanks to PCBWay. Alright, but what about those extension cables? Okay, I'm going to clear the desk, and we'll get these extension cables made, and I'll show you what the deal is with those. Alright. Bit of tape on top to hold it together. And then that's got to go on there. So this is a little bit tricky because they're not all nice and joined together, only by the tape. So I'm going to have to get my head in the way and peer into this to make sure they all line up properly. But so I'll probably have to do this off camera. But I'm sure you can do it. I do believe in you. So I'll get this crimped up, and then I'll show the finished result. Alright, so I've got our two cables, all nice and altered as needed. Fantastic. So I've got to make 4 adapters. So I'll make one small one rather than all 4 of them, because that'll just get tedious. And we've got to make sure, I think we've got to make sure they're the right way around on each end, but we'll just make one for now, and they'll work from there. So we've got the, you can see the pins. We're going to bend them in. So I'll just put it on the table and bend it a bit, if I can get enough force behind it. There we go. Alright, I'm going to have to do some adjustments here. And then I'll get them so they're just right to hold the PCB by themselves. A little bit too much again. Maybe about that. Yeah, that's good. Just like that. So now I can solder all that up. One side done. So that is going to go in that way. Alright, pin 1 is on the top. A1, B1 and C1 for the 3 rows. But we're only using 2 rows, so it's A and C1. And then pin 1 is there, so that wants to go like that. So that's going to be bent in just a little bit. If I can. Oh! A little tiny bit there. Oh! Yeah. Yep. Sweet. That's looking good. And there is one adapter made. So that will plug into the unit, and then we can plug that one into there. Or the other way around, doesn't matter. But that will have the same on the other end, just with the female side. That side with one of them. And we've got our extension cable. So I'm going to go ahead and make the other ones. And once it's done, we'll give them a try and see what happens if we turn this thing on with all the stuff hanging out. Alright, so we're all connected up here. Everything's discorded all over the desk. So I've got the CPU board here with the new battery. That's got the extender cable coming into there. And we can access that board inside. There's some adjustments and whatnot. And then on this side is the same thing. We've got the extender cable there. And you can see in there I can access all the adjustments. And down here, that's just an SMB to SMB cable that I got from eBay. I wasn't going to make one of them. We can buy them pretty cheap, so that's good. And then we've got the extension cable here coming from the main frame. So that is all ready to turn on. I've got the BNC cable here coming up to the scope, so we can see if it's going to kick out a waveform. So let's turn this on. Oops. There we are, it's booting up. 1000 Hertz at 5 volts, so let's turn the output on. And what do we get? Awesome. So that is working. Fantastic. Enthusiastic thumbs up. And special thanks to PCBWay again for supplying the PCBs. That's all good. So now I can start calibrating. Excellent. Well, that's all we got for this video. So I hope you found that informative and somewhat interesting. Like, subscribe, all that sort of stuff down below. You'll find the files linked down below, and PCBWay as well to get the PCBs made. And I guess we'll see you in the next one. See you then.